Okay, so we're generating solutions for separable ODE problems. So in the first one, we have the ODE that f prime of x is equal to negative f of x. Another way of saying that is dy dx is equal to negative y. All right, so if we work this out, we're going to get negative 1 over y dy is equal to dx. And then we just take the integral of both sides. The integral of the left side is going to be the negative natural log of y is equal to x plus some constant. Now you don't need a constant on both sides, you just need it on one to make things work. We're given an initial value where y is 1 when x is 1. So we have that the negative natural log of 1 is equal to 1 plus c. So 0 is 1 plus c, which means c is negative 1. All right, so let's go back and plug that in for the c. The negative natural log of y is equal to x minus 1. That means that the natural log of y is 1 minus x. And if I take e of both sides, you get y is equal to e to the 1 minus x, which looks like answer C. So that's problem number 1. Okay, so let's look at problem number 2. We're given the differential equation dy dx is equal to negative x over y e to the x squared. And we have this for only f of x is greater than 0. And so we also have an initial value of 0, 2. Right, so let's work this out. We're going to get y dy is equal to negative x over y e to the x squared. We take the integral of both sides. 1/2 y squared is equal to, I'm going to leave this alone for a minute. Oops, that y shouldn't be there because we moved it over here. Okay, so e to the x squared. And we're going to play this as u substitution. There's a dx there and a dx here. You can rewrite this a little bit. Negative y squared is equal to the integral of negative x e to the negative x squared dx, right? So just let u be negative x squared. That means that du dx is negative 2x, which means that dx is du over negative 2x. So, all right, that's going to give me 1/2 y squared is equal to the integral of negative x e to the u du over negative 2x. Let's get a little bit of room here. I have 1/2 y squared is equal to the 1/2 the integral of e to the u du. So 1/2 y squared is 1/2 e to the u plus c. Let's switch back from u's to x's. So that's going to give me 1/2 y squared is 1/2 e to the negative x squared plus, now the constant has to change there, right? Because we're back to x's, so we're going to call that C2. All right, so our initial value here is that y is 2 when x is 0. So that's 1/2 times 2 squared plus 1/2 e is equal to, e to the 0 plus c2. So 2 is equal to 1/2 plus c2. which means that C2 is 3/2. All right, so let me get some more space here for a minute. All right, so let's rewrite this with that new C2 value. I have 1/2 y squared is equal to 1/2 e to the negative x squared plus 3/2, right? So we're going to multiply everything by 2. That's going to give me y squared is equal to e to the negative x squared plus 3. Take the square root. And I know I'm positive because of the restriction that they gave me on the range of this in the problem. So I can go with that. Oops. That shouldn't be a C. That should be a 3 there, right? Okay. And that's my answer. So that's D. All right. So let's move on. All right. So in problem 3, I have the differential equation dy dt is equal to negative 2y when we have y is equal to 1 when t is equal to 0, right? So this is going to give me 1 over y dy is negative 2 dt. Take the integral of both sides. I'm going to get the natural log of y is equal to negative 2t plus c. Now, we know that when the pair y is 1 and t is 0, right? So this means 0 is equal to 0 plus c. This means that c is 0. So my equation at this point is the natural log of y is equal to negative 2t. Right? So problem wants to know what is t when y is a half. So this is going to give me the natural log of 1/2 is negative 2t. Take e of both sides. 1/2 is equal to... Oh, I see what we did here. Wait a minute, we have to isolate t. So let's just divide both sides by negative 2. The negative natural log of 1/2 over 2 is equal to t. The negative power comes up, so this means that I have the natural log of 1/2 to the negative 1 over 2 is t, so the natural log of 2 over 2 is t. So that's problem C. So a little fancy footwork there with the laws of logarithms, but otherwise we're in good shape. All right, so let's look at number 4. We have that dy dx is equal to 3x squared y. So 1 over y dy is equal to 3x squared dx. We take integral of both sides, right? The 1 over y, I think you're seeing a pattern here that the natural log likes to come up in these problems, right? So the natural log of y here has to equal x cubed plus some constant. We know that we have the point 0.8 in the curve, so the natural log of 8 is equal to 0 cubed plus the constant, so the constant is equal to the natural log of 8. Alright, so filling that in, the natural log of y is equal to x cubed plus the natural log of 8. If I take e of both sides, I get y is e to the x cubed plus the natural log of 8, which means that y is equal to e to the x cubed times e to the natural log of 8, but this is just 8. So y is 8e to the x cubed. That would be answer A. Okay. Let's look at number 5. We have that dy dx is equal to 2y squared. And we have the initial value when x is 1, y is negative 1. So let's start by separating this out. We get y to the negative 2 dy is equal to 2 dx. Take the integral of both sides. You should get negative y to the negative 1 is equal to 2x plus c. Another way of writing this is negative 1 over y is equal to 2x plus c, right? The initial value, y is negative 1. So that's going to become 1 over here. When x is 1, so that's going to be 2. So that means c is negative 1. So rewriting this, I get negative 1 over y is equal to 2x minus 1. The question asks, when x is 2, what is y? So negative 1 over y is equal to 2 times 2 minus 1. Negative 1 over y is equal to 3. Cross multiplying gives me 3y is negative 1, which means y is negative 1/3. That is B. Okay, so this is actually a problem dealing with exponential growth. This is an exponential growth model because the rate of change is equal to some constant times y. So we'll see in a few classes that this is the typical exponential growth model. Kind of timely in our world of COVID-19 here, but we'll see what happens when we work this all out. So what we end up with here in number 6 is 1 over y dy is equal to k dt. We take the integral of both sides, gives me the natural log of y is equal to kt plus some constant. So y, oops, let's not go there yet. So now the question becomes like, what happens here? Which one of these could be a possible answer? And it looks a little weird, right? So let's take e of both sides. We get y is equal to e to the kt plus c, which is y e to the kt times e to the c. Now, what's going to happen here is e to the c is a constant. So I'm going to call that c2. Now, if I do that, I get something in the form of y equals some constant e to the kt, which is the typical exponential growth equation. And given no other information for problem number 6 here, the one that actually works as a possible solution is B, because that constant could be 2. We just don't have an initial value to work from. Looking at problem 7, we have basically, we're being told that dy dx is equal to 2x plus 3, right? That's the slope at every point along the curve. So let's separate that out. Dy is going to equal to x plus 3 dx. So y is x squared plus 3x plus some constant, right? We have an initial value in this problem, which is 1, 2. So 2 is 1 squared plus 3 times 1 plus c. So 2 is 4 plus c, which means c is negative 2. So y is x squared plus 3x minus 2. Right? So that looks like D. There you go. Okay, looking at problem 8, we're given that dy dx is x squared over y. So if we separate that out, we get y dy is equal to x squared dx. We integrate, we get 1/2 y squared is equal to 1/3 x cubed plus some constant. Now we have an initial value in this problem, right, which is 3, -2. So 1/2 -2 squared is equal to 1/3 3 cubed plus the constant. So this is 2. And this is going to be 27/3, which is 9, which makes the constant -7. So 1/2 y squared is equal to 1/3 x cubed minus 7. All right, so let's multiply everything by 2. Y squared is equal to 2/3 x cubed minus 14. Take a square root. Gives me 2x cubed over 3 minus 14 inside the square root, which is d. Okay, so let's look at problem number 9. Problem number 9 is dy dx is equal to 2 sine x. So dy is equal to 2 sine x dx. Take the antiderivative. Y is equal to -2 cosine x plus some constant. We have an initial value of pi 1, so 1 is equal to -2 cosine of pi plus c. The cosine of pi is -1, so 1 is equal to 2 plus c, which means c is -1. So we should get y is equal to -2 cosine x minus 1. All right, there you go. That should be letter D in that problem. Okay, looking at number 10, we have dy dx is e to the y plus x. And we have an initial value of 0, negative natural log of 4. So we have to do a little work at the outset of this, because this becomes e to the y, e to the x. So we get e to the negative y dy is equal to e to the x dx. Antiderivative of that. So we're going to get negative e to the negative y is equal to e to the x plus constant. Right? All right, so we get the point 0 natural log of 4. So this is e to the natural log of 4 is e to the 0 plus c. So this is -4, this is 1, which means c should be -5. So negative e to the negative y is equal to e to the x minus 5. All right, so let's take the natural log of everything, right? Or, well, let's deal with the negative first. E to the negative y is 5 minus e to the x. Negative y is going to equal the natural log of 5 minus e to the x, which means y is equal to negative the natural log of 5 minus e to the x, which is, I think, one of the answer choices. Oh, they did this negative natural log of negative e to the x plus 5. And that guy is C. All right, so I hope you're happy, healthy, and safe out there. And these are your Separable ODE Solutions. So again, if you have questions, email, bring it to the drop-in. We'll make it work. I hope you're all well. Thank you.